So when it comes to anything these days, the best laid plans of mice and men always go astray. So I bought this Renogy starter kit from Amazon. Here it is right here. Renogy starter kit. And it came with a Renogy RNG 100D SS panel. So my thought was, after testing this, that I would buy a second panel and we would mount it on this roll-around rack. See, it's under construction here. And in that way, I could get 2 panels on this rack instead of 1. And 2 panels, why 2 panels? Well, because then you don't have all your eggs in one basket. One panel gets smashed, the other one still works. So I thought 2 would be better than 1. So I ordered a second Renogy panel. Here it is right here. Same part number, RNG 100D SS. Got it right here, RNG 100D SS. There's only one problem. It's the same model number, but it's not the same panel. Not even close. Now look at the specifications here. Here's the dimensions. 41.8, 20.9, 1.38 inches. So that's 41.8, 20.9. Oh, let's look at this RNG 100 DS panel. Dimensions 42.2, 19.6, 1.38. They're completely different sizes, and as you can see, the mounting brackets don't line up. Look at the difference on the bottom. Oh wait, let me flip these around. It's not just the dimensions that differ. The pattern is completely different. The first one that I bought, which was part of the starter kit, is on the left. The second one that I bought is on the right. Those panels don't look the same. Look at that top bracket. Even the mounting holes for the top bracket, they're way off. They don't line up. The bottom bracket is close. The top is off. And let's look at the construction. This first one that came with the starter kit is all metal. This has some sort of a blue plastic corner. These panels, even though they're both marked Renogy, they're totally different. They're not the same model number, even though they're marked with the same model number. I just don't know what to say. I know that they're not going on this rack. It would look ridiculous. So that's our first problem. Now, here's another thing I notice. Even though the gauge is not marked, if you compare these two cables, the cable from the original panel is much thicker than the cable on the second panel. Even the cables are different. Okay, here's our digital caliper set to 0. This is from the July 2022 cable. 5.23 millimeter, 5.25. Okay, here's the August 2021 panel, the cable from that panel. Set it back to 0. Let's try again. .76 millimeter. I would say that's quite a difference. So, the dimensions are different. The mounting bracket locations are different. The construction is different. the visual nature of the patterns is different. They couldn't be more different. I just don't know what to say. All right, so let's look at an alternate system. So this is a Hazard Fraught 100-watt solar panel from our favorite local tool store. It's a totally different size from the Renogy, and I just thought I would mention that there are two different SKUs on this, so I'm not sure what the other ones might look like. This one here is a 57325. 57325. Alright, it does not come with mounting brackets, and they don't sell the mounting brackets, but there are 4 holes. And the Renogy brackets do fit this panel. They fit fine. The problem is there's no holes on this side. So there's holes on the width, there's no holes on the length. So if you planned to mount it this way, there's no attaching the brackets to the side. Now let's go look at those Renogy panels. I have them on the length right now, but if I wanted to, look at all the holes I have here. I could have mounted them on the width. Plenty of holes here on the width. In fact, every corner has lots of holes. Both panels are made this way. Mounting holes vertically and horizontally. On this panel, all we have are horizontal mounting holes. And that's a problem because here's how I wanted to mount it. So it just so happens that this panel is the perfect size to mount right here. Perfect. Between the corner board and the window, perfect size. The only problem is there are no mounting holes here for the brackets. So they don't want you to drill holes into here. In the event that your drill should slip, it would hit the panel and crack the panel. So not as easy as you might think to drill holes where there are no holes. What would it have cost Harbor Freight to put holes all the way around this panel? They didn't. There's another gotcha. Hazard Fraught. The next hazard has to do with wire gauge. Here's my sidewall pass-through, and I have an extension here. This is an I. Greeley extension, and we can clearly see, if I can get it somewhere, 12 AWG. So that's American wire gauge, size 12. So it's a 12 AWG cable, size 12, clearly marked. What size cable do we have on the back of this Thunderbolt panel? Well, you can examine this cable very, very carefully. It's not marked. It's not marked. And additionally, the black wire looks to be a little thicker, has thicker insulation than the red wire. Could be an optical illusion. I don't know. It's not marked. So if we put this side by side with the extension, we can see this is a lot thinner. So if that's a number 12, what size is this? No thicker than a 14, that's for sure, and that's a guess. It's not listed online, not marked here on the back of the panel. It's not in the instruction manual, not anywhere in the specifications. What size wire is this? Nobody knows. All right, let's go look at the Renogy. These wires are specified as 10 AWG, meaning 10 gauge. I don't see it marked, but it's a very thick cable. So these aren't marked either. They're specified as 10 gauge cables, specified everywhere in the online instructions, in the ads for the product. I can tell you this though, if that's a 10 gauge cable, and this is a 10 gauge cable, that one is a lot thicker than this one, but they're both 10 gauge. This panel has MC4 connectors. These can be taken apart. Once you put them together, you need this tool. The tool goes in these holes. They're not quick disconnects. I don't know how many times you can connect them and disconnect them. These are really made for a semi-permanent installation. So MC4 connector on these two panels. The Thunderbolt panel has an SAEJ connector. You don't need any tool to plug this into an extension. You don't need any tool to disconnect it. It's made for quick connect and quick disconnect. Now, one of the things that you want to notice is that this panel has the red wire on the female connection. So red goes to female, and the black wire is on the male connection. So the black wire to the male prong, red, which would be your hot, is on the female. Now when you plug this into an extension, let's go look at that iGreeley extension. When you plug this into an extension, you can plug it in either way. So the right way to plug this in, you want to keep red to red, black to black, so you plug the female into the male. That keeps the red going. Here, let me go grab that panel and do that. Okay, here's the connector off of the panel. Red is on the female. And if you're going to do it right, see, red is on the male here. So you plug these two together, and the red continues. Red to red, black to black. So you wouldn't think that it would be possible to do this wrong, but what if I inadvertently used this side of the cable? The side that I just took out of the sidewall connector. What happens if I put it together this way? Uh-oh. Look at it. Black is going to red. Red is going to black. So you can easily make a mistake here and get reverse polarity. You have to pay attention. You can't just plug these together. You've got to keep the colors matched up. But wait, it gets much worse. Okay, I've got these connected. So red is to red. We're keeping our polarity correct. And come now to this end. What happens, I've got two different sidewall connectors here. This one on my right hand is a 12 gauge. This one in my left hand is a 10 gauge. You can see that the one in my left hand is a lot thicker. And also, notice that the red is on the bottom on this one. The red is on the top on this one. So you would think that one of these is going to be correct, but it's, and here's your weather cap. So you'd think that one of these is going to be backwards and one of these is going to be correct. Well, they're both wrong. So here's the plug. We've got red all the way through, red to red. Notice that the hot wire, the red wire, is on the female side of the connector. So let's go into this one. Female side is right here. When we plug it in, what just happened? We reversed polarity. We now have red on the black, we have black on the red. Well, that's okay. The other one has got to be right. Alright, let's plug into this one. what just happened? They're both wrong. Black is on the red, red is on the black. How can that be? Because it's not whether the red is on the top or the bottom, it's whether it's on the female socket or not. And you'll see that both of these, even though they're upside down from each other, both of these have red expecting the male pin. Both of them. And the system requires that red accept the female pin. So both of these cause you to have a reverse polarity error that you have to correct by either putting this in backwards so that you have two mistakes makes one correction. It's crazy. It's another gotcha. It's another gotcha. And that's why I'm showing it to you. Okay, it's the next day. Here's our backup power system that we described in episode 1 that runs the well pump when the power goes out. Here is the back of the sidewall connector right up there that we put in, that we showed on the outside of the house. Now the reason it's so difficult, or the reason you're so easily tricked by reverse polarity gotchas, is because the sidewall connector would be the very first thing you put in. You would drill a hole through the plate, the sill plate, with a 3/4 inch spade bit. You'd screw that down and just assume that the color codes and the polarity is going to be correct. It's not. And that's why you're easily tripped up. The system doesn't work. You don't know why. It's because of the polarity area that I showed you outside. So okay, now the next thing, that you have an extension. The extension just draws down and comes to a charge controller. So this charge controller, I bought this one on Amazon. It works amazingly well. I like this a lot better than the Renogy 30 amp Wanderer. This is a 30 amp charge controller. It can handle 4 panels. I've got 2 panels on it right now. So let me show you what's happening. The display indicates 13.1 volts. That's my battery voltage at this moment. This arrow shows that the solar panel is charging the battery. And this arrow, which goes to the right, shows that the excess energy being produced by my solar panels is going to a load. You turn this load on, undefined load, with this button. Now generally when you look that up, whoa, what's the load? The load is something that you run directly off solar energy. It's not running off the battery, not right now, because right now those panels are pumping. And they're pumping more amps than this battery, which is a boat battery that I'm testing with down here, more amps than this battery needs to be maintained. So I've got a little refrigerator connected to it. This is a 12 volt, 4 amp refrigerator. It's very useful for people who need to keep prescription medication cold. So in the event of a grid down situation, if you have insulin or some other medication that you have to keep cold, I just saw that in an episode of Colony. I think it was the very first episode of Colony TV show. Well, this will do it. So how is that working right at the moment? Let's grab our clamp meter. This is a DC clamp meter. Turned it on here to 40 amps DC. Okay, we've got it on 40 amps. We'll zero the meter with this button. Alright, now how much juice is going into the refrigerator? Well, I already know from experience that both of these panels are putting out about 6 amps. I have 2 panels on this right now. One Thunderbolt, one Renogy. The Thunderbolt actually puts out a lot more than a Renogy. So we're going to clip this. Normally you'd press hold if you couldn't see it, but we can see it. We're putting 3.5 amps, I'll round that off, 3.5 amps into the refrigerator. Now those 3.5 amps, they would have just been dumped and not used right now because we don't need to charge this battery with 12 amps. So let's see what's going into the battery. Oh, 3.5 amps, all solar energy, running my refrigerator at this moment. All right, we're going to zero the meter again. There we go. Here's our battery. 3.5 up there. I can't see what I'm doing, so I'm going to press the yellow hold button. We're putting 1.24 into the battery. So 3.5 plus 1.24, that's 475. Right now we are wasting about 6 amps of solar energy. So the battery doesn't need it. The refrigerator is only taking 3.5 amps. So we're wasting about 6 amps of solar energy. There must be very bright sun at the moment. 2 panels, overkill at the moment. 2 panels on a partly cloudy day, or maybe mostly cloudy day, might be enough, might be more than enough, might be exactly what we need. So that's how you play the panels versus the energy. Right now we're producing more energy than we're using, and my refrigerator is running completely, entirely, 100% on solar energy. So let's just open it up, see what the temperature is in there. 38 degrees, pretty good. Okay, now what about this stuff? We have 2 USB jacks for charging. They work pretty good. I'll put my little USB meter in it. And we got, can we read that? Turn this off maybe. We're not drawing any amps right now on the USB because we've got nothing plugged into it. 5.09 volts. No amps being drawn. That works great. I think for the money, this little charge controller, it can handle 4 100-watt panels. It's a 30 amp charge controller. So 4 times 6 amps per panel. 6 4s are 24, gives us some headroom. It really works amazingly well for what they charge. Now the only thing I don't like about this charge controller, black writing on black plastic makes it very hard to read these icons, to see what's plus, what's minus, and so on. Now, the manual also allows you to make settings on this charge controller. It's not really understood very well, but here's the procedure. This is the menu button. You have to hold this down for 7 seconds to enter the menus. Then you have to let up and tap it again. So let's try that. Hazard Fraught. And this time the hazard is the user. I'm going to hold it down for 7 seconds. 2 America, 3 America, 4 America, 5 America, 6 America, 7 America. Let up, tap. Okay, that's our cutoff voltage. The next setting is our kick-in voltage. The next setting, oh, maybe that's the, I don't know, I have to look at the manual. But that's how you enter the menu, right here. I'm still testing this system. I am amazed at how much power these panels put out. The fact that you can do this with just one solar panel and eliminate that little battery maintainer down there, where you see the red LED. The fact that you can run a refrigerator with one panel and really run it very well with 2 panels. Just amazing. So we'll have more to say about this when I finalize my system. But for very short money, you can be independent of the grid. Grid can go down. There can be no gasoline. There can be no hope of the grid coming back. And you still be able to pump water, run the furnace, keep your medicine cool, and charge your battery with just a panel or 2. Simply amazing. Okay, we made a statement. that the Harbor Freight panel put out more amps, more volts, more amps than the Renogy panel. So that would be more watts. Let's prove it. Set our meter to DC volts. We'll disconnect the Renogy panel. Alright, we get 19.54 volts on the Renogy panel. Alright, we'll disconnect the Harbor Freight. .93 volts on the Harbor Freight Thunderbolt panel. That's 2 volts higher. It's always about 10% higher than the Renogy. Both now in full sunlight. Alright, let's check the amps. Connect them both back up. Alright, first we'll measure the Renogy panel. We'll put our meter on 40 amps DC. We'll zero it. Alright, 0. Supposed to be perpendicular to the cable. I'm going to press the hold button. What did we get? 4.56 amps DC. Alright, let's try the Harbor Freight one. Meter's at 0. Okay, this one's the Harbor Freight panel. Try to get it exactly perpendicular. Press the hold button. 5.52 amps. That's more than 1 amp greater than the Renogy is putting out. So between the two of these right now I've got about 10 amps. But once again, by my math, Harbor Freight's putting out about 20% more current. Hard to believe, but Thunderbolt beats that Renogy. There's your proof. So I know what you're thinking. Why don't I just set up these panels on the front lawn? There are videos of people doing this all over the internet. This is a big lawn. Plenty of room here to create my own little solar farm. Well, here's the answer. In the wintertime, there's usually a snowbank here on the side of the driveway that's up to my knees. And if we have a particularly severe winter, it's up to my waist. So if you live down south, that's an option. If you live here in the Northeast like I do, that's only a summertime option. It's not practical in the wintertime. And that's why I wanted to mount it high on the corner of the house. If that panel were mounted here, it would be well above the snow line. A second panel mounted here would also be above the snow line. We would have our west sun, our south sun. That's not going to work for me except in summertime. And so that is why I wanted to do something like this with two panels, not just one. Here's my knee. My knee is right up to this line. That's my typical snow by the side of the driveway. So this would be just about above the driveway snow. The plan was to put this on wheels. It could be kept here in the garage, rolled out as needed. At the moment I'm looking at a 100-watt solar cart. I'd rather have a 200-watt solar cart. All I know is I've got panels from two different companies, both throwing all kinds of gotchas at customers. Kind of frustrating. Well, I hope you found this video useful. I hope you're now aware of the problems you're likely to be running into if you decide to do something like this. I just can't explain how two identical model number panels can be so different from a company that is so widely respected and acclaimed. This is just crazy. So we'll see what's going to happen, and I hope this helps someone. Thanks for watching.